Hello students, welcome to chapter number 13, limits and derivative. Students, after ending our major parts of limits, today we going our new parts, that is the most IMP parts, that is a derivative. Yes students, in this chapter we studied a basic derivative for our functions. And this derivative basic formula you also utilize next year in 12th science. So properly by heart the first formula. So I will give you first formula for derivative. First of all, definition of the derivative is f dash x. F dash x means first order derivative. Sometimes f double dash x, so second order derivative. Yes, formula is that limit h tends to 0 f of x plus h minus fx upon h. That's our first formula to our definitions derivative. Now secondly we going ddx of, ddx means derivative for respect to x, x raised to n. Formula is nx raised to n minus 1. Third, ddx of, if you given x only, x derivative respect to x is always 1. Third, now fourth, ddx of constant. Any constant derivative is always 0 where c is constant. Now any constant derivative always 0. Now continue question number 5. Derivative of ddx of our root x function. Root x derivative, it means nothing, it is x raised to n related. Just see here this formula, x raised to half, and half you apply here, n is half, so half x raised to half minus 1, it is the minus half, it means 1 by x raised to half. It means you will write down that 2 times root x. So this is the property for root x derivative, always you by heart what? 1 by 2 root x. That's your differentiation derivative. Now continue 6. ddx of any exponential functions to e raised to x. Answer always e raised to x. Next, ddx of, if you given a raised to x, so a raised to x log a to the base e. Now 8th one, ddx of log x to the base e, always which is 1 by x. This is a basic formula you by heart must be write down at least 5 times, students. ddx of, now log x, now after that 1 upon x, it should be minus 1 by x square. Now I will start to trigonometric related our derivative functions. After that x, e raised to x root x and log x. ddx of sine function. Next, ddx of cos x function. These are both very easy. Sine derivative is a cos x and cos derivative is a minus sine x. Very easy, you will just by heart into 2 pairing values. 12th, ddx of tan x, and 13, ddx of cot x. Now tan derivative is a sec square x and cot derivative is a minus cos x square x. Now continue 14, ddx of sec x, and 15th one, ddx of cosec x. These are simple 2 pairing you by heart. First by heart this 2, secondly that 2, and lastly that 2. Now sec x derivative is a sec x into tan x, and cosec x derivative is a minus cosec x into cot x. These are the simple basic formula. In this derivative you must be by heart to 1 to 15, and also for working rules. So now I will go to students working rules. Only 4 there are working rules. So working rule also students you by heart before operating any derivative formula. working rule of the derivative. You also know working rule for the limits. Here working rule of our formula to derivative. So first working rule is the d dx of any u plus v function. Both are variable. So du by dx, dv by dx. Just like to addition separation. Second, u minus v given if you both subtraction du by dx minus d by dx if you both subtract them. Now third is a product rule, u into v. Product rule very easy, simple. Apply the product, first second derivative plus second first derivative. I mean u dv by dx plus v du by dx. Sometimes it's extra given for the three terms u, v, w. Then you also write down in the three ways the product rule. First of all, u derivative, vw same. Secondly, u same, v derivative, w same. And last, u same, v same, but w derivative. These are our third way, simple, our product rule. And fourth, last one, which is a division rule, d by dx, u by v. Our division rule very easy. In denominator square, v square, always by heart. In denominator square, v square. Now v du by dx minus u dv by dx. Formula again I repeat. In denominator square. Now start in numerator, numerator derivative minus numerator denominator derivative. So v du by dx minus u, your formula to dv by dx. These are the simple our 4 working rules. And after that, students, I will start now little our examples. So in example running, students, example number 8. Example start in the derivative solve by the rule of definitions. Very easy. Find the derivative of function is fx given 3x at x is equal to 2. Fx is equal to 3x and x is equal to 2. Question is there, find derivative of given fx 3x at x is equal to 2. So you start first fx and f of x plus h. Very easy. In place of x we will show x plus h. So my value is a 3x plus 3h, and by definition your derivative f dash x, which is limit h tends to 0, f of x plus h minus fx upon h, and value put it, limit h tends to 0, it should be 3x plus 3h minus 3x by h, cancel, only you have 3h by h. So limit h tends to 0, 3h by h, and h also gone, you only have to 3 f dash x, means derivative over. But you asking here at x is equal to 2, so you show that at x is equal to 2, f dash 2, in place of x you will submit only 2 value, means your answer is 3. Continue example 9. Similarly going is a given function fx. Yes students, 9 is a IMP for exam. It is most IMP numerical. Yes, for given fx is applying that, and some also asking derivative and some proofing. Fx is a 2x square 3x minus 5. 2x square plus 3x minus 5, and find derivative at x is equal to minus 1. Also prove that our f dash 0 plus 3 times f dash minus 1 is equal to 0. That should prove. After that, f dash 0 plus 3 f dash minus 1 is equal to 0, and question is 2x square plus 3x minus 5 at x is equal to minus 1. So students, first of all I start our derivative up to that x is equal to minus 1. So my given fx 2x square 3x minus 5, and take in converting f of x plus h, 2 with x plus h square, 3 with x plus h, and minus 5. Now you will expand to all in the functions by definition. F dash x, limit h tends to 0, f of x plus h minus fx upon h, and both value know that apply to respectively in your given data. So one of the that 2 times x plus h whole square, 3 f of x plus h minus fx, it means this fx students, 2x square 3x minus 5, and upon h is same as. Now you will try to a big expansion systematically, one by one all expansion you will do, and like term cancellations. So here I expand it totally. So limit h tends to 0, x square plus 2hx plus h square, next 3x plus 3h, and that students minus 5 same as 2 up to that. Now this minus multiply inside, so minus 2x square minus 3x plus 5, and upon h as it is. This cancel, plus 5 minus 5, this also cancel, plus 3x minus 3x, and other expansion one by one. So f dash x is equal to this same 2x square. Now 4hx, next 2h square, these are multiplications, and other here also same, plus 3h, next minus 2x square, and upon h same as, limit also students as it is, write down limit h tends to 0. Now you will check this cancel to 2x square, and other functions you just take common h. So f dash x is equal to limit h tends to 0, h common in this parts, h common. So remaining are 4x, 2h, 3 by h, this h and this h successfully cancel, and apply your limit h tends to 0. So my answer f dash x is equal to 4x 0 plus 3. It should be 4x plus 3, and that's your derivative very easily to this given functions. You're done here. Now I want to derivative at the place of minus 1. So at x is equal to minus 1, you will show minus 1, 4 into minus 1 plus 3, here apply in place of x, exactly minus 1. So your answer is minus 4 plus 3, which is minus 4, minus 1. Now that over, now your target achieved to secondly f dash 0 plus 3 f dash minus 1 is equal to 0. Already f dash minus 1 done, so I will show to 0. So at x is equal to 0, f dash 0, in this parts you put down x place is 0. So your answer is 4 into 0 plus 3, 0 plus 3, It is only 3. Now our target achieved to this part, LHS, proving f dash 0 plus 3 times f dash minus 1. F dash 0 is 3 and f dash minus 1 is a minus 1. So your answer is 3 minus 3. It is 0. Check. RHS is done. Therefore, we can say f dash 0 3 times f dash minus 1 is equal to 0 is true. Now here you are proving easily and successfully, students. Done. Now I continue. Example number 10. 10 also very easy and very simple. Question is there in the 10th example. Derivative at x is equal to 0 for the sin x. Find derivative of sin x at question given x is equal to 0. You know, students, sin derivative you know already. Sin derivative is a cos x. But I will prove here after the definitions going. So fx it is should be sin x. F of x plus h is a sine of x plus h. And now go to simple form our definitions for the derivative. So f dash x derivative, limit h tends to 0, f of x plus h minus fx upon h, and put down their values. It is a sin x plus h minus sin x by h. And now you know that s minus s, sin minus sin, which is 2 cos sin. Trigonometric students formula 2 cos sin. Both angle dividing by 2 upon h same. Here adding the terms x plus h plus x. Both subtracted x plus h minus x. Surely you x and x just like cancel. So only I have limit h tends to 0, 2 cos 2x plus h by 2. Here sin h by 2 upon h. So does this h by 2? This 2 if I divided with that and collect from this, surely it is again 1 for our working rule. So I easily derive my answer for the derivative of sin x functions. So now I continue in the way of further calculations. Again I repeat, this 2 is divided at and arrange with sin h by 2. So f dash x, limit h tends to 0. Here cos of 2x plus h by 2. And other working rule is same. H by 2 tends to 0 is that. And another only sin h by 2 upon h by 2 by working rule of the limits. Yes, limits working rule. That is the one. And here apply limit in the way of 2x plus h. So f dash x, students, cos of 2x plus 0 by 2. That's the one. So my answer is cos x. Yes, students, in the formula list according to your this sin derivative is cos x here done. But I want to at x is equal to 0. So continue. At x is equal to 0. We will show f dash 0, cos 0, and cos 0 is also you know that it is 1. And here this numerical happily done. Now example number 11. 11 also same way. Question is there, fx is equal to 3 and derivative asking find derivative at x is equal to in the way of one of the 0 and one of the 3. So at x is equal to 0 and x is equal to 3. Students, already it is a constant function and constant derivative 0. So my answer is finally it is 0. Fx I will take 3, x plus h also 3, and definition, by definition of the limits f dash x, limit h tends to 0, f of x plus h minus fx by h, and apply the simplest form 1 by 1, and simply apply in the definitions forming value and you will get answer. So limit h tends to 0 where the f dash x. Students, here in the both way it is a constant only, so 3 minus 3 it is 0. So at x is equal to 0, f dash 0 0, and second at x is equal to 3 also 0. Now continue example number 12. Also given the function fx and find the derivative for that related questions. Fx is equal to 10x. Yes, example 12. Fx is a 10x. Find its derivative. I mean f dash x. So does 10x derivative directly also written 10x derivative 1? Means your answer is 10. But I go to definition. Fx is 10x. X plus h. 10 with x plus h. It means 10x plus 10h. And simply you will apply the form of your definitions. F dash x, limit h tends to 0, f of x plus h minus fx by h, and put down values 1 by 1. So limit h tends to 0, f of x plus h is a 10x plus 10h. Fx also is known, students, 10x, and upon h same this and that happily and easily cutting. Limit another same 10h by h, that also cancel, and your answer is only and only 10. Again I repeat, you shortcutly apply also 10, x derivative 1, so it is your answer is only 10. Now continue example number 13. Very easy numerical and very simple way we going. Now 13 is a x square. Example 13. Fx is a given x square. Find its derivative to f dash x. So students, you know shortcutly x raised to 2 derivative is just like x raised to n and x raised to n minus 1. So 2x raised to 2 minus 1. Your answer is 2x. But I will go to now definition wise x plus h whole square and apply the simple way definition rule. F dash x, limit h tends to 0, f of x plus h minus fx upon h, and apply the functions in place of fx and f of x plus h. So limit h tends to 0, it is x plus h whole square minus x square by h. Now students, here you will show whole square expansion. Only I have 1 of the x square plus 2hx plus h square minus x square by h. Check this x square and x square successfully going. Remaining have you just common take h and cutting down that. So h tends to 0. Here h common. So 2x plus h by h. Students, this also cancel. And remaining h, apply the 0 limits. So 2x plus 0 in place of h, I will show that 0. My answer is only 2x with the f dash x. That's your answer. You also shortcutly going x raised to n formula. apply if you direct getting 2x raised to 2 minus 1, it means only 2x. Now continue example 14. That also same way running. Now in the 14 your function is there. Yes, only fx is equal to a. It is constant. Fx is equal to a. A is any fixed constant. Then find its derivative f dash x. So it is constant derivative as well as it is 0. I just show the definitions. A f of x plus h is also a, and my definition is f dash x is equal to h tends to 0 by h. Simply apply the definition of our first principle, h tends to 0, a minus a, that's become only and only 0. Now continue example 15. And question is there again given sin x fx 1 by x and find its derivative. Fx is a 1 by x, find its derivative with respect to x. So simple, I apply. Already I written this formula in the list today students. In the first started 1 upon x derivative minus 1 by x square. But here I prove why it is that. So I just write down x plus h 1 by x plus h and apply in the definitions. Indirectly any functions you given, you will show by definitions wise your derivative. By definition of the derivative, f dash x limit h tends to 0, f of x plus h minus fx by h, and show your data. My data is ready. 1 upon x plus h minus 1 upon x and upon h is as usual. Now I will take to LCM. So limit h tends to 0. These are LCM, x minus h upon x plus h into x into h, and these two are just cutting. Remaining I have limit h tends to 0 minus h upon x plus h, x and h. These also cancel students, and other apply the limit h tends to 0. So my answer is minus 1 by x plus 0 into x. Finally my answer is minus 1 by x square, and that's your f dash x students. You ready that for any derivative of 1 upon x, always you will show that derivative minus 1 by x square. Yes students, here after ending our question number 15 examples, here stop this video students, and this part also I stop here, and further explanations to next part I will explain to in further related our derivatives. Okay students, bye bye.